All right, so today we're going to be going over the 4H today. So we looked at the other day, we looked at transition matrices. And if you remember, we knew that one of the things we knew about them, they were square. And we also remember that the columns add up to 1. So we had to 1. So, and we use them to make predictions of like what's going to happen in the future. So today we are going to set up a way, and it's sort of like a formula. So when they say a recursion, it's like steps that you always follow to get the next one. So that's all that recursion means. It's like when we use a formula and we use the steps, we use the same step or same process to get the next, term or the next thing, the next set of numbers. All right. So we will use that word recursion also in our finances this year. So we're just going to get used to it. So let's have a look at what we said. So consider the earlier example of going to the movies and staying home. So we talked about if we talked about having a transition, and we said movies, they went on a Saturday night, it was movies or stay at home. And we worked out that transition. So we now ask questions. We're going to get told how many people were at each of those. And we want to know what's going to happen in the next week or in the next 2 weeks. How many are going to be at the movies or how many are going to be at the staying home. So a recurrence relation can be formed. So it's like a rule. So don't worry. It just means a rule that we're going to use to model, so a rule to explain how we go from week to week. So the starting point of this example is a matrix that tells us how many people initially, so how many we have in the beginning at everything. So for this example, we might say that we have 200 people at the movies and 150 originally stayed home. So if you want to say that, so there was 200 people originally at the movies one week, and then 150 people stayed home. Okay, so this is what they call it, S0. So this is S meaning a state matrix. So a state matrix tells you the people. So we use a transition to shuffle it or to predict the future, and then the state matrix tells us how many. So at SO, we know that's the beginning. So when you go to get S1, this would be the next week. So, this is the week after SO, yeah? So 1, and then S2 would be the week after S1 and so on. So the way we can get that is when we want to know how many people are at each venue or each spot in week 1, you can see we do the transition here times SO. So if we remember how we do manual multiplication, so remember we go that row with this column. So you can see 0.2 with 200 and then 0.4 with 150. So when you times that out, you end up with this answer. So we've got the top answer was movies, and that's the bottom number was stay at home. So then you can say, so after 1 week, we now have 100 people at movies, and we have 250 at stay at home. Okay, so if you look at it, sometimes then we often talk about how many people there were in total. So if you go up here, how many people were there in total? There was 200, 350, 200 plus that. So when you look, even after week 1, see, it still adds up to 350. You don't lose any people when it's just straightforward finding week after week. So this was a town, so we're just finding out where they are moving to. So that number should stay the same. Okay, so then we have a look. If we want to find week 2, you can see we use this transition again, but we use the we now use week 1, because that how we get the next week is we use the week before. So then if I do that, so you can see here, this is S1 there. We've popped that in and we get that. So if we want to keep going, if we wanted to get S3, we do use the S2 answer and so on. And this is what you call is recursion. Recursion, this what it means. It's when you use the one before to get the next one. Okay, that's what recursion means. I'll just say the next state. Okay, so that's what recursion means. So it just means like that. So I'm telling you now, when you use transitions, you can always get the following week if you've got what happened the week before, and you can just keep on going and going and going. So here, as I said, recurrence is just a rule. It just means it's a formula of how to do it. But when we are asked to write a rule, with this a recurrence rule, we always have to give initially what was at the start. So we will give SO. So if you're ever asked to, so this is the start scenario, if you want to write that. So you have to give what the start scenario is. So you have to have SO written, and then they'll tell you, then they write this, and this is the rule. Now, all that means when they write SN plus 1, that just means the next term, yeah, or the next state. So how I get the next state is I use the state before. So the next state using the state before. And that's what recursion is, all right? So let's have a look. So they're just really repeating that there. So let's have a look at this example here. There we go. I'll pause it. Okay, so let's have a look at this example here. So it says children at a fair can either go on the Ferris wheel or the merry-go-round. Now, 140 children were on the Ferris wheel and 80 were on the merry-go-round. So you can see here they're setting up SO. So they said that this was Ferris wheel and this is merry-go-round. Okay, so because we know that the top number is Ferris wheel and the bottom number is merry-go-round, you know on your transition that this must be F and this must be M, and that's how they've set it up. So if I look at that, just by looking at that, boys, how many people, what percentage of people who were at the Ferris wheel go back to the Ferris wheel? What percentage go? 80%, because we can see F to F is 0.8. That's what I was just asking. All right, so let's have a look. It says to predict the number of children on the Ferris wheel and merry-go-round after 1 turn and after 3 turns. So we know if we want state 1, we have to go, we have to use the transition times the one before. So if for this example, just for this one, you can get away with just showing you're working out using the codes, but just to show you what we're actually going to do, we're going to type in this transition matrix in our calculator, because you don't have to manually do it. We can just use our calculator. So I'm going to times it by that SO. Okay, so then if you have a look, let's just to be checked. So this was a 2 by 2. This is a 2 by 1. It will produce a 2 by 1, won't it? Yeah, which is what we want. Okay, so let's do this on our calculator. So you can just watch at the moment. So I have popped that in there. So I'm going to use this. There's the, oh, that's not the transition. Is that it? Yep. So here we go. So we've got the first transition there, and we're going to times it by the SO, which is there. Press enter, and then I go enter. So I can see that 136 and 84, that's S1. So if I go on and I want to get S2, I'm going to look and go the transition times the one before, which would be S1. So on your calculator, if you have a look up, all I'm going to do is highlight up the one before and press enter. And then I'm going to go and edit this one and make it what it is. So 36. And then we need to do it up to, up to turn 3. But first of all, let's just do S2. So we've got S2 equaling 134 and 86. So this is S2. So when I go to find after 3 turns, I'm going to do the transition times S2, which will equal, so I'm just going to highlight it. So if you press the up key, when you've got what you want, press enter, it drops it down, and then we're going to edit here. So I wanted 134 and I wanted 86 on the bottom. I want 86 on the bottom and press enter. So we end up with 133 and 87. Now we have to remember to make sure we answer the question. So this was the top number was Ferris wheel. This was merry-go-round. This is Ferris and merry-go-round. So when it says predict the number of children after 1 turn and 3 turns, so if you just pop that up here, you could say there, after 1 turn, we had 136 on the Ferris, and then 84 on the merry-go-round, and then down here, after 3 turns, so maybe if we were writing an answer, so after 3 turns, there's 133 on the Ferris, and 87 on the merry. We can shorten it, that's okay. All right, so I'm going to pause